Alright, Algebra 2, we're going to add to our notes just a little bit today. So this is the stuff we did yesterday. We were transforming inverse functions So you have your book. I'm going to put the book on page 102, and that's because we're actually going to put something else on 101 probably on Monday. So on 102 I have my book. I'm going to go through this pretty quickly because I think you guys caught on pretty well yesterday. But if you're wanting me to slow down, remember you can always pause and rewatch this video if you need to. Okay, so if I look more closely at the front here, the shape of this graph is called a hyperbola. We always have a horizontal asymptote in general at x equals h. In this case here, h is 0. A vertical asymptote at y equals, oh my gosh, did I just get those backwards? I totally did. These are swapped. Y equals k. In this case it's 0. So those are really swapped, my bad. The domain is going to be all real, except x cannot be whatever h is. And then range is all real, except y cannot be whatever k is. Now in this case it passes through 1, 1, and -1, -1, but that's not always the case. And that was the part you were complaining about on the front that you thought was super confusing yesterday. So we weren't really using that all too much. Okay, if we go through the first part right here, this should be super fast and easy to go through. If I work my way backwards, we know that k, if it's positive, it's going to move the graph up. If it's negative, it's going down. We have our horizontal asymptote and that the range cannot be that value. On the bottom here, when we're looking at x, if it's x minus, we know we're really going right. If it's x plus, we're really going left. That is my vertical asymptote. Also, the domain x cannot be that. Over here, when we start talking about a, when a is greater than 1, that's going to deal with my slope. So it's going to make that slope larger or smaller. We were treating it as slope. If it's less than 1, then we flip so that it's increasing. I think this is supposed to be decreasing. But it is slope. A over 1 is a slope. Oh yeah, so that's what that, yep, decreasing. So A over 1 is our slope. Okay, so describe each graph as it's compared. I'm going to do like 2 of them with you, and you guys can try the last if you like. The slope hasn't changed at all. This is showing me here that it's moved left 5, and over here down 7. This graph is decreasing because the slope is positive. If I look at C, because the slope is 6, I know that it's going faster, so faster because slope is 6. It's also decreasing because it's positive, and it got moved right, 6. We could also probably add some stuff about our domain and range, but we'll leave it at that. Okay, if we try graphing a few, if I look at B, I know that my h comma k is -3 comma 0, so that really tells me my horizontal and vertical asymptotes. My horizontal is y equals 0. My vertical is x equal -3. My slope is 2. So we were using this yesterday as our new origin. It still is, so my new origin is right here. I draw out my asymptotes. And then from there, I'm going to do my slope, which is 2. So up 2 over 1. And then also down 2 over 1. Then I just need to sketch so that my graphs get close to the asymptotes, but they do not touch. Oh my gosh, that's bad. Down here, I know that my domain is all real, except x cannot be -3. And range is all real, except y cannot be 0. And if I do a quick reminder of the negatives with you, so I know my h comma k, or my new origin, is 0. 3. So here, which means if I draw my new x and y axis out right here, my horizontal asymptote is at y equals 3. The vertical is at x equals 0. My slope is negative 1. So then, starting at my new origin, I'm going to go down 1 over 1 to keep it in the negative quadrant, and also up 1, back 1. So everything just switches quadrants so that we are in the negative quadrants. My domain is all real. X cannot be 0. And range is all real. Y cannot be 3. So hopefully that's a nice little reminder. If we look over here, we're going to do the opposite of that. So where we're writing the equations, I'll try B and C with you. So if I look at B, I look at these 2 points and I find right in the middle, which is here. So my h comma k is 6 comma 2, which means that h is 6 and k is 2. And if I compare how these changed, I went down 1 over 1 to get to it, which means my slope is negative 1. Which makes it super easy to fill in my function now. Y equals negative 1 over x minus 6 plus 2. I picked this one because it was a little bit trickier to find the middle. So I know the middle is here. And the way that I'm kind of looking at it is I just want to find the middle of these 2 points. What is exactly between negative 1 comma negative 8 and 1 comma negative 2. So right in between these two values is 0, and I know that because that's 1 away and 1 away. Kind of what I'm doing is I'm really adding them and dividing by 2. So if I add those, that's 0 divided by 2, which is 0. If I add these two, I get negative 10. Divide by 2 is negative 5, which I'm pretty sure is exactly in between those two. And if you graph it, you should feel pretty confident that that is right in the middle. It's like 3 away from 8 and 3 away from 2. So that being said, that means h is 0, k is negative 5. The slope is how much it takes me to get from that center to this point. So if I count 1, 2, 3 over 1, that means my slope is 3. And it is positive because it's in the positive quadrants. You can also draw in your asymptotes to see if you feel good about where your center is, if that's helpful to you. Which just tells me that my equation is y equals 3 over x minus 0, so I don't really have to put it, minus 5. That's a super sneaky one, so if you needed me to do that again, just, hit rewind. It's all good. And that's it. So good luck with what you're trying today.